So yeah, I'm here to talk about RITA. I kind of wanted to start with the help scrape because if you've used RITA before, you may remember there was a show beacons command. There was a show beacons web command. There was a show long connections command. There was a show open connections. There was 10 different show commands to be able to go through and look at what data RITA can present for you. And we've got it down to a view one in that set. So I'm super excited about that. So a little bit of background for the folks that haven't played around with RITA. So RITA is an open source threat hunting tool. RITA is named after John's mom. Awesome person. We have built this into the back end of our commercial product to make sure it always gets updated and will never die. So RITA is probably going to outlive all of us in this room, which is great. RITA is designed to identify command and control channels. So the concept is somebody comes in or somebody, sends me a phishing email. I click something I shouldn't have. I run something I shouldn't have. They own that box. Now they want to be able to take remote control access to it. The way that works is this box just starts calling out to a command and control server, and the attacker connects to the command and control server. That gives them control of the box itself. What's the methodology that's used? Oh, it's all over the place. I have a free intro to threat hunting class. Take that, because you can use DNS. You can go through content delivery networks. Folks get really creative on how they go about setting up those C2 channels. But despite all that creativity, RITA is designed to spot them for you. So that little tag about look for needles in big haystacks. Yeah, that's what it's designed to do. So if you had like 1 million connections go out to the internet yesterday, but buried in there is one compromised system, this is the tool that's going to help you go through and try and identify that. We have a couple of different things. So RITA doesn't listen on the network itself. It leverages other tools for that. And we have a couple of different protocols we support, but the one that we really like the most is Zeek. If you're not familiar with Zeek, please get familiar with Zeek. Zeek is, despite being involved with creating this stuff, Zeek is my favorite tool. It's my favorite tool because it's a network recorder, and it gives you a running record of everything that goes by on your wire. Think PCAPs and 120 at the storage space, which is nice, and that's what Zeek goes through and does. But what we do is we have Zeek feed us log entries once per hour, and then we take that hour plus the previous 23 hours, so we've got 24 hours worth of context, and we hunt through that to try and see is there any C2. And what's nice about using that 24-hour windows is that if the command and control channel is running low and slow, if they're only beaconing, once an hour, once every 2 hours or something like that, we'll still pick up on enough data points to say, hey, that's something you need to go in and pay attention to. If your domain name ends in .mil, 24-hour window's not enough. You want to look at like a week or something like that. Yeah, you can actually tweak RITA and it'll do that. It won't keep up with as much bandwidth because you're giving it more data to process. But if you want to be able to analyze a week, that way if you're worried about, oh, hey, what about C2s that only call home every day? Yeah, okay. Spread it out to a week, 2 weeks, you'll be able to pick that stuff up too. But that's nation state. That's usually .gov.mil worrying about that. Commercial side, usually a 24-hour window is enough. Some of the other changes we made. We used to use Mongo as a backend database system. That was not my choice. Please don't blame me for that. That was there before I got involved with the project. But we're using ClickHouse now. And one of the nice things about ClickHouse is about a 20x improvement in speed. So RITA used to tap out at around 5 to 10 gigabit, somewhere in that range there. And from the testing we've done, you can now push it up to about 100 gigabit, which is kind of cool. So we've changed the back end. The other nice little change with RITA is that everything is containerized. Okay, thank you. I'll just be loud. I'm good at that. So the other thing that's kind of fun about RITA is that everything is now containerized. So when I run RITA now, you'll notice it's starting up a bunch of Docker containers as it goes, and then it'll shut them down as soon as it's done. So everything within RITA runs within Docker. Well, that makes it super portable. You may have noticed I'm in the Windows subsystem for Linux running this. Yeah. Reader in the past supported, I think it was RHEL 7, one or two versions of Ubuntu, and then that was about it. Mongo was really tough to kind of get running on a bunch of different things. We haven't really run into a Linux platform we don't support yet. So that's kind of nice. So you can get this to run on a lot of different things. This is kind of cool too. It will tell you, oh, hey, there's a new version of RITA. So I made some comments to my developers this morning, and clearly they already got that pushed up there. So that's always kind of a cool thing. But RITA list will show you any data sets that have been imported. And then if I say RITA view, that's going to go through and let me go in and take a look at those data sets. Let's do the rolling. I think this one's fairly simple. So again, if you used RITA before, big difference in what the interface looks like. It seems like we stripped it down, right? Because there used to be 8 commands to run and now there's only 1. But it's actually doing more than it used to. Everything gets reported in the same interface. So whether it's a web-based beacon, a LAN connection, DNS, whatever, it all shows up here. We also changed from the scoring system to using a severity system that people are more familiar with. You know, if I said, oh, well, that beacon scored a 0.9, do you look at that or not? Well, you got to kind of understand the tool to decide whether you need to look at that or not. But if I tell you, hey, that's critical, most of us know, oh, critical, I need to pay attention to that. Oh, something that's low, yeah, I don't need to worry about that one so much. A lot of the detection we had in RITA in the past is still here, but we've added in some new things. Prevalence. So what prevalence will do is RITA will look at how many hosts have we detected on your internal network, and how many of those have actually talked to this destination out on the internet. So you might see, 800 out of 1,000 show up here. In which case you can look at that and say, hey, 800 of 1,000 of my systems are talking to that host. I don't think I'm compromised. So this is probably going to end up being okay. Whereas if I look in here and it says 1 or worse, 14 of my internal systems are talking to this, that one's probably worth more going in and paying attention to. The other thing we're going to look at is, when was it first seen on your network? So this will kind of not be useful when you first run RITA, but as you let RITA run over time, it becomes more and more useful, and we'll retain that data for 90 days. And after 90 days, this will just say 90 days plus. But think about that. Imagine I have 2 line entries here. One says, oh, this entry was someone first talked to it over 90 days ago. And then the next line entry is, oh, the first time you saw that was 4 hours ago. I think I'm going to go pay attention to the 4-hour one first, right? That's going to end up being a higher priority. So we've pulled that in as part of the scoring system. The other thing we're looking at is what type of signatures are being generated by the system that's the internal system that's currently being checked. So for example, imagine I'm a Windows system, and when I talk to these 10 hosts over here, I use the Microsoft Windows notification user agent string that associates me with being a Windows 10 system. And then I run, I have a bunch of signatures to a bunch of different IPs, and that's all Chrome browser associated with Windows 10. And then I have a signature that claims I'm a Windows 7 system. Well, wait a minute. That's a rare signature. All of a sudden the system thinks it's Windows 7. That doesn't make sense. We'll actually call that out. We'll flag it. We'll pop it up. We're also doing it with J3 hashes if it's a TLS session, which is what you're looking at here. So what this is telling me is that this system is only using that specific hash, or that specific hash of its client hello packet, when it's talking to that specific host there. Other fun stuff we're doing. So here's a connection to completelysafe.honestimnotevil.com. So obviously this one's okay. This one also has a rare signature associated with it. It's the Mosaic web browser running on OS2 Warp version 2.5. Cool. Wait, I don't remember seeing OS2 on my network, so maybe that means something. The other thing we'll look at, actually this one's really fun. So here's the other thing we're looking at too, is we're looking at what are the data types that are being accessed and do they make sense versus the file extension that's associated with it. So for example, this one's popping up saying MIME type mismatch. What does that mean? That means that when this client was connecting to that server, which is also a rare signature saying, I think that's Windows XP, if I remember correctly. NT 5.2, yeah, I think that's Windows XP. But when it's connecting up, it's saying MIME type mismatch. So what it's saying is, hey, this system is trying to access like a JPEG file, which the server should be telling it is an image/JPEG file, right? Because that's the proper client type to associate with that. But instead, it's calling it something else, like text. That one's a really common one you run into with command and control channels, where they want to make the URI look really innocent and make it look like, oh, someone's just looking at an image file, not a big deal. But by setting the MIME type to text, well, now they can run PowerShell commands through that, and it doesn't show up as being immediately obvious. So we'll actually flag that and apply an additional score based on that, just to make sure that that's something you need to go in and take a look at. By the way, all the stuff I'm talking about, I got this link up here. So that has a webcast I did that was kind of a first intro to RITA. It has a series of videos I did on RITA. It also has a blog post on how did I get Zeek and RITA running on Windows, which I'm actually going to go in and kind of talk a little bit about now. So all that stuff is up here. So I considered like throwing slides at you, but who enjoys that? So let's keep it as a live demo, even though sometimes things break. So I got it running on Windows. What is it doing? Well, so I'm cheating a little bit. You can probably tell I'm running WSL2. So what I'm doing is I'm running Zeek and RITA inside of WSL2. So that's the Microsoft's, version of Linux, but it's an Ubuntu system. So that does just fine for me. And then what I'm doing is I'm using dumpcap to actually capture the packets off of the interface for Windows and funnel those over to Zeek and RITA from there. And I'll give you a quick show of what I've got for scripts and stuff like that. This is Hackin. This is not, oh, hey, look, I learned this thing that we can now go deploy out to 1,000 of our endpoints. Yay. No, please don't do that. It's not that stable. But a lot of times we end up in a position where we need to get some good data recording off of a Windows system. This is a good way to go in and kind of get around that. So I got a couple of pieces I pulled together in order to make this work. Oh, and the big problem with this, and this is the one I'm still trying to go through and figure out another way to solve, is that from my virtual machine, I don't have access to the network interface for Windows. I have access to the network interface for the virtual machine, but not for the host sitting behind it. That's the piece I'm trying to go through and get past now. I think it's possible. If you've ever run like Apache, you may notice that all of a sudden Apache's also listening on the Windows network interface. So there's definitely some sort of software tie there. Now all I've got to do is get libpcap working with that, and we don't have to worry about kind of bridging things together. But for now, here's how I go through and do it. So anytime this system starts up, I'm just going in and I'm running WSL. So that gives me my Linux instance running on this box. Also at startup, I run this batch file called sniff.bat. So let's go in and take a look at what that batch file is. So this batch file is just dumpcap. So dumpcap is part of Wireshark/Tshark and all of those fun tools. And it's specifically designed to be able to go in and capture packets off the wire and just write them out to a file as you need to. -F, I'm telling it I want this to be in PCAP format. -B, I'm defining the interval for doing my captures. I'm doing this once a day. You could choose to do it once an hour if you wanted to. But in this case here, I'm doing it once a day. I'm saying maintain 2 files. This is kind of cool because if I was to use like, let's say not TCP dump, Window. If I was to use like Window, I kind of need to come up with another way to manage all these different PCAPs I'm creating. But with dump cap, I can go in with the dash B switch and tell it, I only want to have 2 files max. And now it'll create 2 PCAP files. When it goes to create the third, it just deletes the first one. And I don't really need more than 2 because I'm also sending all of this stuff to Zeek, and we'll get to that in just a second. So maintain 2 max. I'm saying grab 512 bytes off each packet. So I'm not doing a full packet capture here. I'm just grabbing enough so that Zeek gets the data it needs to go through and record what was in the headers. Dash I says, listen on the Windows interface number 5. Dash Q says, don't print out number of packets, the header, all the stuff that normally goes on in dump cap, because I'm running this in the background anyway. You don't need to see any of that. And then dash W, here's what I want to write it out to. And when it creates that file, and I deleted one of these this morning and said, yeah, I probably should have hung on to that until after this lab, but okay. So it'll give it that name plus an extension that has my date timestamp on. So there's my PCAPs. I got a PCAP file. Great. I'm off to a good start. Then what I do is on Linux, I have a cron job that runs on that. And you can set it to run once a day, once an hour, depending upon how often you want to have your Zeek logs created. But that one is the right Zeek one that's up here. And here's what this does. So this goes in and it makes a directory under the Linux, so it's doing it on the C drive, so I can access it from Windows or from the Windows Linux subsystem. Either one will do it. And I'm just using variables here to go in and create a directory that has the current date associated with it. Then I'm going in and I'm running Zeek. Now, if you've used Zeek before, this command might look a little weird to you. Read PCAP. Zeek doesn't have a read PCAP switch. What's this about? Usually if I want to read a PCAP, I use -R. So we've containerized RITA and Zeek. So both RITA and Zeek are running in a container from the host system. I can't talk to them directly. They're in containers. So I need a script to be able to kind of reach into that and execute those things as needed. So this version of Zeek is not the actual binary version of Zeek. It's just a script that recognizes, oh, well, the real Zeek stuff is actually in this container with this name over here that I need to reach out to. And we just decided to give it read PCAP as a switch to use when you want to read PCAPs. Where are the PCAPs located? Where do you want to write out your Zeek logs? Notice I'm writing it out to the directory that I created up here. And that takes care of taking my PCAPs and getting them into Zeek format. Now, once they get into Zeek format, I need to import it into RITA. So one of the challenges with RITA is that, let's get that interface back up. One of the challenges, one of the good things about RITA is it has a graphical interface, and I didn't talk about that. So historically, RITA has always been command line based, and it is still command line based, but there's an ASCII graphical interface that's associated with it now too. So this is based on BubbleTea. BubbleTea is an awesome ASCII graphical interface with a lot of different tools for performing different functions. It makes it real easy to just kind of pull components together and build it. It allows you to colorize things, as you can see. But what I love about this is I can SSH into a Linux server and run this interface, and I've got a graphical interface right within my SSH session. So the upside, I have a graphical interface. The only time I've run into a problem with this is with Smart TTY. Some of you use that for SSH access on Windows. We expected to have 256 colors always available when we go in and we paint this interface, which seems kind of reasonable in the year 2024. As it turns out, Smart TTY still only recognizes 16 colors. And it won't let you do more than 16 colors. So this will work over Smart TTY, but it will look ugly and will look different, but it is still at least functional. But it's an ASCII graphical interface. I can't run this as a cron job because it expects to have a terminal available to it. So here's how I get around that. The way I get around that is to just simply go in and run screen. So I run screen. I give I tell it, yeah, I want to name this session read a role so I can reconnect to it later if I want to. -D-M, here's the command I want to run. So I'm running RITA. I'm telling RITA I want to import into the rolling data set the Zeek logs. And notice I didn't specify a directory name that is a date. I don't have to. What RITA will do is RITA will go to that directory and say, I will import up to the last 5 days all at once. You can tell it to do more of that if you want to. But let's say you've been doing regular updates all the time. RITA will actually go into that directory and say, I already imported that. Oh, there's some stuff over here I haven't imported yet. I'll just grab that and that's it. So it makes it real simple to go through and kind of deploy it out this way. Syntype. So that'll go in and that'll pull that into my reader interface. Once it's there, now I can go in and I can use RITA to go through and do my analysis. So again, not originally designed to run under Windows, but, you know, get bored and hack enough and yeah, you can kind of figure out how to go in and get this stuff running. We're down to like the last 10 minutes. And what I wanted to do is kind of open it up to questions, not just with RITA, but with threat hunting in general. So who is going to be the brave soul to raise their hand first? Because I always find that, like, to get the first person to ask a question, that I got to sit here and stare at everyone and make you uncomfortable for like 30 seconds before someone will do it. But after one person does it, other people will jump in after that. Go for it.
How do you do this at scale? Larger networks.
Good question. So the question was, how do you do this at scale? So there are some limitations on RITA from an at-scale perspective. So for example, palservice.weather.microsoft.com. That's obviously going to end up being something that we're not going to be concerned about. That's just a Windows, well, it's a Windows system calling into Windows notification services. So Microsoft can pop up ads on your system, but also pop up, you know, the weather in this case too. So we'd want to go through and safe list this. If I go into the config.json file for RITA, I can go in and tell it, hey, that fully qualified domain name, never score that anymore. Well, but I got to go in and edit a file. That's a pain in the ass. We have another product called AC Hunter. There's a community edition and a commercial edition. With that tool to go in and create a safe list, there's a little filter icon you can go in and click on. That one is, if you're talking about, I need to do this at a large scale, I don't want to turn this into a sale. So if it's something you're interested in, we can talk offline. But that one is more designed for that because that also includes features. Now you could build this into Reader if you wanted to, but that has built into it the ability to say, hey, this system has something new going on. You need to go pay attention to that now. And it'll send that out as an alert to yourself. RITA doesn't have any of that ability built into it. So not really designed to scale, but there are other options you can work with that are similar. Make sense?
Yep.
Awesome. Any other questions? So the question was, so we're trying to detect C2, but how are we actually going about trying to detect that C2? There's the way that a lot of tools do it, and then there's better ways to go through and do it. So what a lot of tools will use is something called k-means clustering. So if anybody wants to look it up, that's K-MEANS space clustering. But all it is a math algorithm that's designed to look for repetitive patterns in large data sets. So imagine this box is beaconing out to, a system over here, and it's doing it exactly once per minute all day long. K-means will flag that and say, hey, that's something you need to go and pay attention to. And it's nice to look for things in a behavioral analytics standpoint, because now when something new comes out, you can actually go in and detect that. The challenge is every attacker in Red Teamer I've seen in the last 3 years at least use jitter. And jitter means I'm not going to call out once per minute. I'm going to call out once per minute plus or minus 50%. So now it might be the 30-second interval, it might be the 90-second interval. Well, k-means will look at that and say, hey, not repetitive pattern, not my problem. Now you're back to writing signatures. So we've actually gone in and developed our own algorithms around how to go through and detect this. Some of them are timing based. So some of them look for that, hey, over that 24-hour period of time, if I kind of bucket things in, let's say, 15-minute intervals, and then at 1-hour intervals, and then 4-hour intervals, do I start seeing any type of patterns? From a visual perspective, what that's going to end up looking like is if you graph it out, you end up with almost like a flat line across all those time intervals. So we'll go in and we'll look for something like that to tell you, hey, that's something you need to pay attention to. We'll also look for, and I forget what my developers decided to name it, but basically what we look for is there's also C2 where it'll call home at a slow interval, once every 4 hours or something like that. But as soon as you submit commands and it calls in and says, hey, do you have anything for me to do when there's a command set there? It drops to a lower dwell time. So now it'll start checking in every 30 seconds. But if you don't issue commands for, let's say, 5 minutes, it goes back to that longer 4-hour interval. Well, when you map that out over time, you end up with 2 plateaus. So we actually have math to go in and look for the double plateau to go after as well. We also use session size is something we look at. So I don't want to give any red teamers in the room ideas, but one of the things we haven't seen yet in the wild is jittering session size. Certainly you can do it, but I have basically 90% of what's out there for C2 is Cobalt Strike, right? Everybody uses it. Red teamers use it, bad guys use it. Until it gets added into Cobalt Strike as an option, we're probably not going to see it. But we do use session size as a metric to go in and look at as well. And what we look for is that repetitive, hey, do you have anything for me to do? No, go back to sleep. That ends up being a certain session size. Well, let's say there is something for it to do. Run the task list command. Well, that's going to result in a larger session size. So if you think about session size on a graph, right? Smallest size over here, largest size over here. If my big peak is over here, but now I see no peaks or maybe some much smaller peaks over here on the right, that could be C2. That might be something worth going in and paying attention to. So we have a bunch of algorithms along those lines. It's all behavioral based. None of it's based on signatures. Cool. Any other questions?
Flagging off the destination IP also, or
so the question was, are we flagging off of the destination IP address also or not? No, we don't. But you can feed in IPs and fully qualified domain names. And if any of your traffic's trying to go there, we will say, hey, it's going there. With RITA, I don't want this to come out wrong, but with RITA, it's kind of dumb. With RITA, it's just, hey, it's there. We saw somebody trying to talk to that. With ASCII Hunter, what we do is we'll say, hey, someone tried to talk to something on your threat intel list. So we're going to assign a small number of points to that. But now we're going to start watching what's that client doing when it's talking to that target. Because if you think about the typical false positive, right? So like it was a C2 server and now it's Jane and Bob's Pizza Shop, which just happens to be down the street and everybody's ordering pizza, right? How much data will that client send to Jane and Bob's Pizza Shop? Not much. It's going to send its SSL hello packet, any URI for any data it wants to access, user agent string, that's it. So what we do with ASCII Hunter, just because we get a little bit more intelligence we can build into the back, we'll assign a small number of points when it hits that thing on your list, but then we'll stop monitoring the number of bytes sent. If it stays less than 5 megabytes, that initial score that got assigned is it, and that's it. If it exceeds 5 megabytes, we start adding in additional points. There's a second threshold that by default, and you can change these, is set at 25 megabytes. And if it gets to 25 megabytes, we've thrown 100 points at it to make sure it shows up at the very top of your list. What's nice about that is you can have a threat intel list that has like a 60 or 70% false positive rate, which unfortunately a lot of the open source lists do, and we'll normalize out a lot of those false positives for you.
So not long ago, we found something that looked like a C2 channel that turned out to be a developer trying to measure how fast it's on a regular basis, like a service. So I've been seeing more and more applications with some kind of application metrics going back for measuring
Yes.
or communication Are you guys flagging a lot of false positives on it?
So what we're doing, so I'm getting into the commercial product, and this was supposed to be an open source talk, so I'll keep this part brief. If you want to come by the booth and look at it, feel free. But one of the things we've added in is we've added in hints to ASCII Hunter. So what the hints are going to do is when something is talking to something like that, we'll flag it like it's C2, but we'll have a little light bulb there. And you can click the light bulb and you can say, so what do you know about this? And it will tell you, hey, this is used for this type of metric collection. My issue with that is there are some things that you can say it's okay to safe list, right? Network time, NTP servers, no problem. Patching servers, no problem. What about something like TeamViewer? Yeah, all right. TeamViewer, is it good or bad? Well, it depends. Did you know it was there already? Right? I've done thread hunts where we've said, do you have TeamViewer running? Oh yeah, we have TeamViewer on these 2 boxes right here. And then we go in and we do our audit, and now all of a sudden we're finding it on like 14 or 15 different systems. Well, in that case there it was, here, TeamViewer good, 14 of the 15 other ones, TeamViewer bad. One of them, it actually ended up being really bad. So this was a hospital that had hired a company to manage some medical database, and they were just completely incompetent. So they said, that's it, we're done with you guys, we're not going to pay you. They ended up in court with each other. The hospital lost and didn't have to pay them, which probably pissed off the consulting company. But that happened 3 years ago, and one of the TeamViewer servers we found was their remote access in. It was still active. So they could have come in and trashed the hospital anytime if they wanted to. Yeah, that was really bad. So for stuff like that, we're going to start adding in notes so you have the context you need to kind of figure out, is this something you want or not? I mentioned Windows notification services. For some folks, they look at that and say, well, it's just Windows calling home. I don't care. I'll add a safe list to that. I just want to ignore it. But for other folks, they look at that and it's like, wait a minute, they're pushing crap out to my Windows system. If that's happening, I want to know about it. So that's another good option for going in and creating a note. And with that said, I think we're down to the bottom of the hour. Thanks, folks.